Good day, folks. Today we are going to take a look at how to use properties to simplify logarithmic expressions. And we're also going to be able to translate between logarithms in any type of base, because usually your calculator just handles base e and base 10. Well, today I'm going to show you what you can do if your logarithm is in another type of base and still allow your calculator to be able to calculate that. Alright, so our do today to express as a simple log the example that I gave you right here. Alright, well, let's get started. Okay, to get our heads into the game here a little bit, I want you to do these 7 problems. So real quickly, just write them down, quickly do them, and then we'll uncover and talk about them here in a moment. So go ahead and pause the video. Okay guys, taking a look at this one, it says simplify. You have like bases, so what do you do to the powers? Well, yep, that's right, add them. Okay, so now what do you do if you're dividing? Well, if you're dividing, what do you do to the powers? Okay, if you said subtraction, I agree. Okay, now here you have a power to a power. What did we do when we did a power to a power? Correct, we multiply. Good. Now, let's review these here. Remember, the base of the exponent becomes the base of the log, inside-outside switch. So express it as an in exponential forms, and here's what it will look like for the first one. And for the second one, here's what it will look like. Alright, now that we reviewed a little bit, getting our heads into the game here, let's go on with our lesson. To start out with today, let's review what we did last class period. Remember we had a example problem that dealt with milk and lemon juice, and I think the other one was orange juice, and we found the pH value of those. Well, today, remembering that problem, and notice what we did here. So in that previous lesson, we had a formula like this, and we found that it can be expressed so it looks like this. All right, now, keeping that in mind, because logarithms are exponents, so remember, logarithms are exponents, you can derive the properties of logarithms from properties of exponents. Okay, so the part that I've underlined here, I want you to pause the video and get that down in your notes, but write it on the left-hand side, put a little star by it, so it's like a little note in your notes. Okay, pause the video. Okay, let's begin these properties. First of all, I want you to notice here, you have b to the m, and you have b to the n. Now, like bases, what do? Yes, add them. So that's b to the m plus n. Good. Now, let's take a look at this property of logarithm. And the property of logarithm says if you have the log base b of m times n. Now notice, up here you had multiplying. Here you multiply. So when you multiply, what do we do up here? When we put them together under one base, you added them. So here you're going backwards with it, so you're breaking them up. So for multiplication, that equals log base b of m plus log base b of n. All right, go ahead and pause the video so you can get that property down. Now let's do an example with that. What's going to happen if I have log of 4 base 6 plus log of 9 base 6, and notice we have log and the base is the same. So what can I do? Well, if I am adding them, that means multiply. Correct. So here's what it looks like. So here we have log base 6 of 4 times 9, or 36. Now, let's simplify that. How do we simplify that? Well, let's think here. Ask yourself this question. Here's a little hint over here. 6 to the what power is 36? Because remember, 6 is the base. So 6 to the what power is 36? Correct. You said 2. I heard you all the way over here. So anyway, here we go. So it's going to be 2 for an answer. All right. Let's do another. Well, another property, that is. Okay, so again, first of all, let's remember, what did we do when I divided like bases? Well, okay, m and n. What did I do to the m and n? Well, yes, we subtracted it. So I want you to pause the video here in a moment, and I want you to write this down. Because logarithms are exponents, subtracting logarithms with the same base is the same as finding the logarithms of the quotient with that base. Now, what all does that mean? Well, let's go on to a property here in a second. For right now, pause this and get this down. Now, I want you to write it in a little place off to the left as kind of an asterisk, okay? All right, pause the video. Okay, all right, here's our property. So, what do we have here? Well, let's look at it. We have log base b, I have m divided by n. Now, so since it's m divided by n, when we divide like bases for exponents, that meant we subtract. That way for logs, it's m log of m base b, subtract log of n base b. All right. Oh, and a little note here before we move on. I want you to notice here, properties above can be used in reverse. In other words, if it is in this form, you can take it over to look like this. Or if it's in this form, you take it and make it look like this. Now, how do you know which way to do it? Well, guys, here's what I'm going to do. I will ask you to expand the logarithm. If I say expand the logarithm, that means I want you to go this way. From here to there is expanding it. If I'm asking you to condense it, then I want you to go from here that way. All right. Go ahead and pause the video if you need and get this down in your notes. Okay, let's do this problem here. Okay, we have log of 100 base 5, log of 4 base 5. Notice my bases are the same. So since my bases are the same and I'm subtracting, subtraction means what? You said it. It means division. Okay, so that means it's going to be 100 divided by 4, which is 25. And then remember to ask yourself this question. 5 to the what power equals 25? Correct. 2. That is correct. So there is our answer. Okay, now we're ready for our third property. Remember, it's the logarithmic power property. So let's look at it. All right. So now remember here. Let me remind you here. When you had a power to a power, what did you do? Yes, you multiplied it. Well, likewise with this, something similar to same. I have log base b of a raised to a power. I can take that power and I can pull it out front. Okay, so I take that power right there and I pull it out front. And it becomes p times log base b of a. Okay, pause this and make sure you get that property down. And then we'll go practice a few examples. Okay, here's our examples. We have here log of 32 base 2 raised to the 6. Since it's raised to the 6, what do I do with that 6? Correct, you pull it out front. So it's going to look like this. All right, now think with me here. 2 to the what power is 32? Correct, 2 to the 5th is 32. So that means we're going to, that log of 32 base 2 is actually just a 5. And then, of course, 5 times 6 gives us 30, and there we go. All right, now, let's take a look at the next one here. What do we have here? I have log of 4 base 8. All right, so what can I do with this power there? You got it. Pull it out front. So let's pull this out front. All right, then I have 20 times the log of 4. Okay, now we have to think. 8 to the what power? 8 to the what power is a 4. Now, that one's a little bit tricky, okay, because you don't see right off the bat 8 to the what power is 4. So, and let me just tell you what it is, and I made a little note right over here for you. 8 to the 2/3 power is 4, okay? So, that means I'm going to plug right here a 2/3, and then, of course, 8 times 2/3 gives you 20 over 3, and there's our answer. Okay, we're going to take a look at 2 more properties, and these are called the inverse properties of logarithms and exponents. Now, here's what it says. It says if the base of the exponent is the same as the base of the log, it's the logarithm of that base is going to be just the power. Again, so the logarithm, if the base of the exponent is the same as the base of the log, that logarithm will be equal to just the exponent. In other words, it's kind of like this, and I'm going to use this terminology. It's kind of like the base of the exponent and the base of the log, if they're the same, they log out. And you're left with just x. Now, same with this one here. The base of the exponent is the same as the base of the log. So what's going to happen? Well, and by the way, this is not an official term or anything like that, official saying. It's my saying. They log out, and leaving you with just x. All right, so let's take a look at an example here. Okay, here we go. I have log of 3 base 3. All right, so since this is the same as this, you know that they log out, leaving you with just this. So our answer is 11. Okay, let's take a look at this one here. Now, sometimes we have to think and we have to change things. 3 to the what power is 81? Well, think with me. 3 times 3 times 3 times 3 is 81. Okay, so 3 to the 4th. Now, notice here, the base of the exponent here, same as the base of the log, so it logs out, and you're left with just a 4. All right, and let's look at this one. Here's another one here. Notice here, base of the exponent, same as the base of the log, so they log out, leaving us with, what is it going to be? Yep, you said it. It's going to be a 10. All right, guys, you're getting good at this. Oh, but hold the phone here a second. What happens if you don't see a base? Like right here, you don't see a base. If you don't see a base, that means it's a what? Yes, common log. And if it's a common log, what does that tell me? Right here it's going to be. That common log has a base of 10, isn't it? Which means it's still going to log out, leaving you with an answer of, you said it, 0.9. All right, let's take a look at part B here. In part B, what do you see? 2 for an exponent, 2 for a base. It logs out, leaving me with 8x. That's right. Good job. Okay, all right. Now, we are almost done with this. So we're getting very, very, very close. And you've done a great job here. But we need to look at what are we going to do with a situation where the exponent, well, let's say I can't figure it out. Let me just put it that way. I can't figure out what the log of it is. How do I handle it then? Well, let's take a look next at what we're going to do with that. Okay, here's how we're going to handle that. We have a formula called the change of base formula. And let's say hypothetically here, or maybe not hypothetically, that I gave you a problem like this. Log of base 4 of 8. And I ask you, what is that log? And you're saying, my calculator won't handle it. I don't know. How do I do it? Well, this is the formula that we're going to use there. We're going to take the log, and we're going to use a common log. We're going to take the log, and notice it says an a right there. Log base a of x, because you could change it into any log you wanted. Most of the time we're going to use common log though. So we have log of x base a, and that's this x right there. And we have log of b base a, that's that b right there. So if I want to find the logarithm of this, I just take the log, the common log of x, divided by the common log of b, and plug that into my calculator, and it gives me my answer. So let's go practice a problem like that. Okay, here's a problem. I give you log of 8 base 32. Okay, so that's a very difficult one to find. So we're going to use a common log and plug it in the change of base formula. So remember, I told you we were going to do the log of 8 divided by the log of 32. So here it is, log of 8 over log of 32. And then you're going to take that, punch it into your calculator, and when you punch it into the top, it gives you this. You punch it into the bottom, it gives you that. And then you divide that, and it gives us 0.6. 0.6 for the log of 8 base 32. All right, now, where can we use all this log stuff? Well, guess what, guys? Let's go take a look at where we can use it in real life. Remember what a Richter scale was? Yes, it dealt with earthquakes. And we're going to take a look at a situation here of a situation that happened back in 2004 dealing with a tsunami. Okay, so let's look at an application problem here. Okay, it says the tsunami that devastated part of Asia in December of 2004 was spawned by an earthquake with magnitude 9.3. How many times as much energy did that earthquake release compared to the 6.9 magnitude earthquake that struck San Francisco in 1989? Okay, now, here is the formula that we are going to be using right here. Now, M here stands for magnitude, and then this is the formula here. E here, that deals with the energy release. Okay? All right, so what we're going to do is we're going to take this 9.3 up here because I want to figure the energy released by the earthquake causing the tsunami that occurred in 2004. I'm going to plug that right there, and we're going to solve this problem. Okay, now, go ahead and get this down in your notes. Pause it if you need to. I'm going to run ahead, and I'm going to continue to work through this. Okay, so here's the problem here. The first thing I wanted to do is I wanted to multiply both sides by the reciprocal, 3/2. So there it is. That divides this stuff off right here. And I'm left with log of E over 10 raised to the 11.8. All right, now, I have division here. So I'm going to expand this log. So I have the log of E divided by the log of 10 raised to the 11.8. Now, I'm going to use a common log. Why? Because what is that base right there? Yes, it's a 10. So what do I want the base of my the base of my log to be? You said it. I want it to be 10. Okay, that is important. Why? Because they log out, don't they? Leaving me with 11.8. So, here's the situation. I have 13.95 equals log of E minus 11.8. So now, what are we going to do to both sides to get this log of E by itself? You said it. Add 11.8 to both sides. Good. All right, what do we do next? Okay, from here we have the log by itself, log base E. So we need to change it from from logarithmic form to exponential form. Now remember, there's a little 10 right there because it's the common log. So remember, the base of the log becomes the base of the exponent. There it is. And then inside outside switch places. So it's going to be 10 raised to the 25.75 equals E. Now, plug that into your calculator, and it'll probably give you a scientific notation, something that looks like that. And that is the magnitude of energy. That's the magnitude of the tsunami, how much energy output it gave. Now, let's do the same thing for the other earthquake. For the other earthquake, again, you're plugging 6.9 in for M, and you're going to walk through the same procedure. So multiply by 3/2. And then you're going to have it down to here. And then from here, what happens? Well, let's see. You have a division here, so it's going to be the base E divided by, so it's going to be a log of E, base 10. Since it's division, it's going to be subtraction. So minus log base 10 of 10 raised to 11.8. You're going to see this logs out, leaving you with 11.8. Okay, after I subtract 11.8 to both sides, I am going to get log base E is equal to 22.15. Now, we're going to take this here. Remember, this is base 10, so it's going to be 10 raised to the 22.5 equals E. So there it is here. We're going to plug that into our calculator. It gives me this. Now, I want to know how many times bigger the tsunami, or how much more energy the tsunami gave out as opposed to the San Francisco earthquake. So I'm going to divide. So you put 10.5 times 10 to the 25th divided by 1.4 times 10 to the 22nd, and it gives us 4,000 times as much as the earthquake in San Francisco. So in other words, it released 4,000 times more energy. Wow, that is a lot. Okay, so there's an application problem of where it is used. Okay, folks, that wraps it up for today. Here is your assignment, and I'll see you in class.